Now we'll study rotational spectra. Rotational spectra arises due to the rotation of molecule. It is called a rigid rotor. There are two atoms M1 and M2 and the distance between them is r. So the reduced mass will be M1 into M2 upon M1 plus M2. So if we calculate the reduced mass of carbon monoxide, then we'll put the value of mass of carbon as 12 upon 6.022 into 10 raised to 23, and the oxygen mass as 16 upon 6.022 into 10 raised to 23, and solve it, and we'll get a value of 1.13 into 10 raised to minus 26 kg. And if we solve for HF and HCl, we'll get the value for HF as 1.55 into 10 raised to minus 27 kg, and for HCl we get 1.61 into 10 raised to minus 27 kg. So what we conclude is that if in a diatomic molecule there is one atom, if there is one atom hydrogen, then we will always get the range of reduced mass as 1.55 to 1.69 into 10 raised to minus 27 kg value. Now any rotating molecule is associated with angular momentum, and it is given by the formula under root of J into J plus 1 H cross, where J is the rotational quantum number and H cross is H by 2 pi, and angular momentum of a rigid rotator is always quantized. Now for the quantum number J, 0, 1, 2, 3 and 4, and these are the values of angular momentum if we solve according to this formula, and energy will be accordingly this. Energy is equals to J plus 1 B. So we'll get these values. Now we know that energy is equals to half I omega square, where I is moment of inertia and omega is angular frequency, and I is equals to mu r square. So we can write this energy as this I omega whole square upon 2I. So I omega is angular momentum, angular momentum L, so L square upon 2I. So putting the value of L, this formula we'll put, and we'll get this J plus 1 H cross whole square upon 2I. Then we can write H cross as H by 2 pi, so we'll arrive at this formula J into J plus 1 H square upon 8 pi square I. So E is equals to Hc nu bar. We know this formula also of energy, so equating both, we get Hc nu bar is equals to J plus 1 H square upon 8 pi square I. So we'll arrive at wave number, nu bar is wave number, wave number is equals to J into J plus 1 H upon 8 pi square IC, and this value H upon 8 pi square IC, it is a constant, so we'll put it as B. So B is equals to H upon 8 pi square IC, which is a rotational constant. So if we write the energy in terms of joules, we will write J into J plus 1 BHC, and if we want energy in terms of centimeter inverse, that is in terms of wave number, then we'll write J into J plus 1 B, and if we divide both the energy terms E upon E bar, then we'll get HC.